Swayam Prabha. Digital India. Educated India.
Hello, welcome to Introduction to Composites. Today is the third day of this particular week, and starting today we will start discussing a specific type of wet process which is known as hand layup. Now, as I mentioned earlier, wet processes are very popular for producing thermoset composites. And the first process we are going to discuss is known as hand layup. And as the name suggests, there is a lot of manual labor involved in the process, and the reason it is known as hand layup is because all the placement of fibers is done manually, and you lay these fibers either layer by layer or in bundle using manual processes. This process is also known as contact layup. This contact layup. This hand layup process is probably the oldest process used to produce composites. It is also relatively inexpensive. So, when I say relatively, it is in context of other processes used for producing composites. It is the least expensive. So, it is less expensive. And when do you use it? You use this process when you have to make small number of parts. So, for instance, if you have to produce 5 particular shapes, 5 shapes of the same type, 5 parts of the same shape, you may use this process. But if you have to produce 50,000 parts of the same shape, then this can become very expensive. So, if the number of parts or if the volume is less, then this is appropriate. Also, it is appropriate when you do not have a lot of money to make expensive tools, because it requires less capital. It requires less capital. What does capital mean? It is money used to produce tools, at least in context of production to produce. So, it requires less amount of tools, it requires less amount of complicated expensive machinery and things like that, because a lot of it is manually driven. What do we produce from this type of process? So, we will give some examples. We produce ducts, we produce swimming pools. Okay. So, you want to make a swimming pool in some home, you dig out stuff, and where exactly you want to make the swimming pool, you use this process and you construct a swimming pool which is integrated with the ground there. So, swimming pools. Furniture, again not in large volumes if the volume is small. Okay. Boats, shells, sheets, but again the caveat here is the volume of production is not large. And so, what do we do in this process? Typically what we do is, suppose I want to make a specific shape. So, what I do is, first I make a mold, then I put inside the mold fibers in the desired orientation, and this process is called fiber layup. And then I put some matrix material I apply pressure and heat, and I also make sure that all the air in the process gets removed, and when the curing happens I do some finishing operation. Okay. So, this is the overall process, fiber layer. So, this fiber layer, putting matrix, all this is manual, okay. It is not automated. So, we will discuss this further, but before that I wanted to put some important comments about mold making. So, this is the first step, this is second step, matrix placement is third, application of pressure and heat, and we have finally finishing. So, we will discuss maybe for a couple of minutes some more detail about mold making. Mold preparation. This is a very important stage in hand layup process. So, suppose I want to make a shape suppose this is the shape I want. So, what do? I make a mold which will have a shape similar to it. Okay. So, this is the first step, I make a mold, and this could be made of something inexpensive. Now, if suppose you want to make a swimming pool, you do not want to make the whole mold of metal, machining and all that will be very expensive. So, you quickly figure out how to make it, make an inexpensive mold, maybe from wood or even from cement and concrete in that, and then what? So, that is the first step more in the preparation, you make the shape, and then if you really are interested in having a good finish, then you do several finishing operations. So, buffing is done as the first step, then you polish the surface, and then on top of this mold you apply a mold release agent, because what you want is that once the composite materials are placed on top of this, you should be able to separate it out from the mold. They should not stick to the mold permanently. Okay. So, this thing is mold release agent. And then, so this is for mold release agent, and to ensure a good finish you also apply a gel coating on top of it. So, you have a mold release agent and then a gel coating. So, these are thin layers. Now, in the picture they look thick, but in reality they are pretty thin layers. So, this is gel coating. And this makes sure that the overall surface has no roughness and it is pretty smooth. So, this is how you broadly do the preparation of the mold, and then you start putting fibers. Now, in context of fibers, I wanted to say two things. You can put fibers in two ways. First way is, so it depends on the requirement. So, there could be a reason why you are interested putting some randomly oriented fibers. Okay. So, the fibers in that case, so if the fibers are randomly oriented, then what you do is you have small length of fibers, and through some nozzle you spray them, and because you are spraying them they fall in all sorts of orientations, and you keep on spraying it on top of the mold, and while you are spraying it on top of the mold, through another nozzle you also spray matrix in fluid state simultaneously. So this is, so here fibers and matrix are sprayed, and the application of matrix and the application of fiber is simultaneously, and because they are sprayed, this type of hand layup process is called spray up process. It is called spray up process. So you have two nozzles, from one nozzle you get fibers, from another, and these are short fibers, they are not continuously long, because they are long then they will not get randomly oriented, they are short fibers. A lot of boats, chairs, all this stuff, they are made from short fiber composites, okay. But you can also use this process to make materials which have long continuous fibers. So this is how you apply the matrix and fibers. The second one is where you have long continuous fibers. So what do you do in this case? So in this case it could be that the top layer, let us say this is the bottommost layer, and you want in the bottom, so here fibers are deposited in layers, they are deposited in layers. So it could be that the bottommost layer is having fibers in this orientation, then the next layer could have fibers, it all depends on what your engineering calculation state, it could be in this direction, then the next layer could have fibers at an angle, and so on and so forth. So what do you do here? You put the first layer of fibers in the required orientation, and that is done by hand, because that is done by hand. And then once you have deposited the first layer of fibers, then you spray matrix material, and then once you have placed the matrix material, you roll the entire surface with some roller, so that extra matrix material gets squished off and also the air bubbles get squished off. Then you place the second layer of fibers, and then again you put matrix, again you roll it so that wetting is proper, air is removed, and layer by layer you build up the whole thing, okay. So this is the second thing, the second way of doing this. Let us look at two pictures which explain this process further. So this picture is about the hand layup process, okay. So what do we see here? So here we have a mold, and you see that the mold is, so suppose you want to make the material which is indicated in dark black, this is the shape we want to produce. So first what we do is we make a mold. So we have a supporting material, we have some other mold form, and we have basically a mold. On top of that, this black portion is a gel coat, okay, to ensure that it gets released from the once you are putting fibers and matrix, it will try to stick to the mold because it is sticky. So you put this gel coat for releasing and also for giving it a good finish. And then in this orange zone is basically several layers of fibers, several layers of fibers. So you put first layer of fiber, then you apply resin, squeeze off the extra material, second layer of fibers, and so on and so forth, and you slowly build it up. So once you have built up the whole thing, and the resin when you are applying, it already has the hardener in it, it already has hardener mixed into it, but you do it at a temperature that the curing rate is very small, it is not high enough. And then once the whole thing is done, then you either apply some heat or you let it remain in that portion and slowly the thing becomes hard. Once the whole thing has hardened, then you take out this orange portion and that is your final product. Okay. So, this is the hand layer process, and most of this work is done by manual, its consolidation is done manually. This is the picture which is a schematic for spray layer process. So, this blue thing is your molding tool. On top of the molding tool, as we had discussed, is the release agent which ensures removal of the part from the mold. To provide finish, you have this red layer which is a gel coat, and then through this tool which has two nozzles, or in this case at least there are, everything is coming from the same hole. So, you have a supply. Okay, so here you have three supplies. You have a supply of fiber, and this fiber is continuous fiber. But remember, in spray layer process we use for randomly orientation. So, inside this blue tool there is a chopper which cuts the fiber into small pieces. So, it cuts it and then it ejects it through this nozzle, and as it passes through the nozzle it also gets mixed with resin, and the resin has two parts, a hardener and a part 1 which is the most of the material. So, when they mix, curing starts. So, all that mixture is deposited in this yellow zone, and then to remove air you keep on rolling it continuously using some rollers, and once the whole thing is done then you let it cure either through heat or just at room temperature. It takes some time, and once you are done you can remove it and then you can trim it at its edges so that it has the final shape. So, the good quality surface in both these processes will be at the interface of the red and the yellow. So, that is the surface which gets exposed to people. So, if your boat, the inside of the boat you want it to look shiny, or it depends which side of the boat you want to look shiny and smooth, that is the side you place at the interface of the red and the yellow zone. So, that is something important to understand. So, that is about the spray layup process. Next we will close this discussion on spray layup process by talking about its advantages and limitations. So, let us look at its advantages and limitations. So, the first one is that you can use this process to make very large parts. You do not really need fancy molds and fancy tools to make complex large contoured surfaces, as we talked about swimming pools and boats and things like that. I have already mentioned that it requires low capital equipment cost, you do not need highly skilled and trained people. So, low skill set, because the concept is simple, and once a person does this couple of times he or she learns it very fast. So, the charge or the expense associated with labor is also not significant, and it is flexible method in case of design changes. Because if the design of your part changes, you can very quickly change the tool, which is the molding thing, and you can again do it. In some other methods, change of the tool becomes very expensive, but here it is not the same thing. And we can make complex features can be developed through use of molded in inserts. Let's look at its limitations. So, this process is slow, and if you want to make 20,000 pools very quickly, then this is not the right way to do it. So, large volume production is expensive. You can make 1, 2, 5, 10 pieces, but if you want to make 50,000 chairs quickly, then this is not the right way to do it. Labor intensive, and this is again which makes it expensive, especially for large production. Typically, suppose you are making a large part, you cannot put that whole mold in a big oven and heat it very easily. Okay? So, what that means is that you leave it at room temperature and let it cure slowly, and what that implies is that the cure time, long cure time, and if it is long cure time, again you cannot produce very large number of parts in short period. Quality control is difficult because it is happening in open environment. So, you do not know at what is the operating temperature, from time to time it will change, humidity in the air changes, all these things change. Okay? So, it is difficult because of open environment and also because it requires significant labor. So, one person does this layup in 3 hours, another person does this layup in 5 hours. The quality of the product will be different because in 3 hours the whole thing is done and its curing process will be different, in another case it will be different. So, it all varies. Typically, good finish is available only on one surface, because the other side is open. You do not ensure the control quality of the other side. Okay? Wastage of materials may be high. And finally, product to product quality varies. So, consistency of the product quality is not assured. So, this is what was intended to be discussed in context of hand layup, and we have said, we discussed that a specific type of hand layup is the spray layup process, and this concludes our discussion on hand layup. Tomorrow we will discuss some other types of wet processes, things like bag molding, RTM, and so on and so forth. So, with this we conclude our discussion, and I hope we meet together and we continue this discussion further. Thank you. Bye.